taking the time to join us today. And we've got some great news to share with you today. Martina already introduced me, but maybe briefly about myself. I'm a technical marketing engineer focusing on our NetSec products or NetSec portfolio, with a great focus on SecureEdge. I'm based in Vienna, Austria, and I have been with Barracuda for 2 years now. You can find my LinkedIn and my email address in the background of my camera. I'm happy to connect with all of you. I'm happy to talk about SecureEdge, answer your questions, and hopefully get you started with SecureEdge soon. About the agenda, really quickly, or just generally what to expect from this webinar. Today's session focuses on SecureEdge and a significant shift that we've made in our infrastructure design, moving towards a more distributed model built around points of presence, as we call them, or PoPs, and flexible access plans that better align security, performance, and scalability. We'll walk through what this shift looks like, why it matters, and how SecureEdge helps bring it all together in a practical and a scalable way. We'll start with an overview of the SASE fundamentals and the SecureEdge infrastructure. This will help explain why we made this evolutionary shift in our infrastructure and how it enables us to make our services easier for customers to buy, deploy, and use. Then we'll take a deep dive into each of the 4 access plans that are available in SecureEdge, and we will finally wrap up with a walkthrough of a real-world use case scenario for DNS access. And I'll also show you how to configure all of this. So before we dive into SecureEdge access plans and the new PoP infrastructure, let's briefly look at the challenges that are kind of driving this change, right? So the first one is the remote connectivity and endpoint risk. So users are no longer sitting behind a single corporate firewall. They are remote, mobile, and often on devices that IT doesn't fully control. So security has to follow the user, not the location. Second one is the application access risk. So users are constantly accessing SaaS applications, cloud applications, and private applications. And controlling who gets access and under which conditions has become a major security challenge for companies. The third one, limited and small IT teams. Many organizations don't have the time or the resources to, manage complex multi-product security environments. So they need solutions that are simple to deploy and easy to operate. And then finally, the hybrid complexity. Customers are dealing with on-prem, like we just said, cloud and SaaS environments at the same time, which traditional architectures struggle to secure consistently. And these challenges are exactly why SecureEdge Access and our global PoP-based architecture exists today. All right, so let's now take a closer look at the SASE solution and its core functionality. Secure Access Service Edge, or SASE, is all about converging network connectivity and security. And for that reason, SASE is typically divided into 2 main components, connectivity and security. And on this slide, you can see this split clearly. We have the WAN edge side that represents the access or the connectivity part of the SASE architecture. While on the other side, we have cloud-delivered security services such as DNS, ZTNA, SWG or Secure Web Gateway, Firewall as a Service, and they make up this secure service edge side of the SASE architecture. Today, we will focus primarily on the right side of the circle, the secure service edge. This part of the architecture and the services that you see here, like DNS, ZTNA, SWG, and Firewall as a Service, they represent a major and evolutionary shift in our infrastructure. We used to offer many of these capabilities in the past, but this new infrastructure model brings them together in a much more unified and cloud-native way which makes it significantly easier for our customers to buy, manage, and consume these services. All right, so this evolutionary shift can be understood as, moving away from hardware-based deployments and kind of also managed services towards a fully cloud-delivered SaaS solution. So all the services now run in virtualized containers in the cloud, and they're hosted in what we call points of presence or PoPs. These PoPs are globally distributed, and all services are already deployed, running, and fully provisioned. And as a result of that, customers no longer need to worry about deploying, managing, or maintaining physical hardware or even virtual appliances. So instead, they simply connect to the nearest point of presence where all the required security and networking services are already available. Now, because hardware is no longer part of the equation, we also introduced a new licensing model that is more user-based, user-centric, right? So the Secure Edge functionality is now grouped into 4 different licensing plans, which we will take a closer look at shortly. And despite this architectural change, the security part remains fully integrated. So we continue to provide advanced next-generation firewall capabilities such as TLS inspection and advanced threat protection, and all the other features that you would expect from a modern firewall platform, right? And in addition, when it comes to DNS security, which is our most basic access plan, we now support fully agentless deployments. And this was something that was not possible previously, at least without hardware. But now we can also support fully agentless deployments. Okay, these plans that you see here, these 4 plans, reflect our licensing model. So DNS access in the top left corner is our most basic plan and provides a simple entry-level solution for DNS security. Then we have internet access on the right side in the top right corner. This is agent-based web security delivered with all the next generation security mechanisms like TLS inspection and advanced threat protection and many more, and also with AI-based content inspection for social media, which we'll talk about later. Then we have private access in the bottom left corner. And this is our ZTNA solution. So it provides secure access to your SaaS applications and also to applications that you host locally on your premises or in your data center. And it provides the secure access to these applications and based on zero trust principles, right? Then we have premium access, which is the last. It's the most powerful plan that we have. It combines DNS security, internet access, and private access. So all of the 3 previously mentioned plans bound together, and you get pretty much with this plan, you get the whole functionality set of Secure Edge with this single plan. All right, let's briefly take a look at the licensing model. So what we have done is we have divided the 4 access plans that I just mentioned into 3 different categories. So we have good, bad, better, and best. Now, in the good category, we have the DNS access, which is, like I just mentioned, it's an entry-level solution. It provides basic DNS web filtering, and it also includes 10 ZTNA seats for testing. And you get the reporting retention period of 7 days for your logs and reports. In the better category, we have our private access and internet access. And private access enables ZTNA use cases, like we just heard, and it also includes DNS security. And DNS security, so the good plan, the DNS access, both private access and internet access include, and also premium access include this DNS access plan. So that's that's the big advantage with this licensing model, is that you never lose a feature as you move um, from a lower tier access plan to a higher tier access plan. And also with private access, you get 30 days of retention period for reporting and logs. And then we have internet access, which is basically a full web security use case with TLS inspection, advanced threat protection, AI-based content inspection, and many more features. With internet access, you also get 30 days of retention period. And then in the best category, we have our premium access plan, which is pretty much all of the three previously mentioned plans combined, and that provides the full secure edge functionality set. All right, let's now dive deeper into the access plans. We're going to look at their individual features and how they work from a higher level technical perspective. Let's start with our entry-level DNS access plan and the different types of deployments that we support with this plan. This is the most basic secure edge access plan. It's focused purely on DNS security, and this plan, provides DNS-based lightweight URL filtering, and it's available in both agent-based and agentless deployments. So how it works on a very high level. The DNS requests are delegated to one of our DNS servers that is running in our PoP infrastructure, right? And they are resolved there and evaluated there based on the policies that you configure. And the answer is then fed back to the client, and the client breaks out locally, right? So like I said, both agentless and agent-based deployments are supported. In the past, agentless deployments required users to be behind like a hardware, a site device or something like, which is no longer the case. It's now fully agentless. And again, you get 7 days of retention period for your data. Now, let's talk about the two deployment options when it comes to agentless DNS access plan or DNS security. How does it work? Again, on a very high level. We're hosting DNS servers in our global PoP infrastructure, and customers start by defining one or more locations in Secure Edge that kind of represent where their users are physically located, right? For example, this could be a small company branch, right? And at each of these locations, there is typically some kind of edge device, right? Like a router or a firewall, and with a public IP address or a range of public IP addresses. And these public IPs are then configured in Secure Edge as part of the DNS location setup. And I'll show you that in the demo later. And once this is in place, once you've configured your DNS location, all the DNS requests from that location are forwarded to our Secure Edge DNS servers. And again, the requests are evaluated there against the policies that you configured to determine, whether the requested website is allowed or blocked. And then if the policies allow access to this specific website, the client will break out locally and, so to say, directly connect to the destination. Now, in these locations, you can be using static public IPs or dynamic public IPs, right? And for dynamic IPs, we have a helper app that you can install that kind of keeps track of your public IP. Unfortunately, there's no user context with agentless deployments. So this option is ideal when user context is not really required, but you still want your devices to have basic DNS security. You don't require any agent on the endpoints. And the good thing is that, like I've already mentioned previously, is that there's no on-prem hardware. There's to deploy or manage. There's no rollout. There's no patching, no maintenance. So none of that. Okay, now let's take a look at the agent-based deployment. It pretty much works in a similar way, but instead you download and install the SecureEdge Access agent on the client device, and you have to enroll the user with the SecureEdge Access agent. And this enrollment process is really like 5 quick steps that you can do in like matter of 2 or 3 minutes, right? Um, how it works then is that the agent connects to our PoP, our point of presence, via TINA tunnel, um, and is sending DNS requests through this tunnel to the DNS server that is running in our PoP infrastructure, right? And then again, as with agentless deployments, based on the configured policies, the access will be either granted or not. And if the access is granted, the agent will break out locally. So for both agentless and agent-based deployments, the agent will always break out locally. Now, the first obvious advantage of this is that this kind of deployment introduces user context, and this allows you to define user and group-based policies and gives you full visibility in your DNS traffic. Like you can check who tried to access what at what time and so on. And another important benefit is that location no longer matters, right? Since the agent is, installed and it's always running, the policies can be consistently enforced, regardless of where the users are, right? At office, at school, in the office, at school, or working remotely from their homes, they always have the agent running, and the policies are constantly enforced. Now, let's go back to agentless deployments. So there's two kinds of deployment. There are two deployment options when it comes to agentless DNS deployment. And this one is not only, but this is like the main use case. This is a deployment option for Chromebooks and tablets and iPads. As you can, for example, see in educational institutes, right? For example, you have students and they get a tablet or a Chromebook, iPad, whatever, and you don't want to roll out an agent on all of these devices, right? And in this case, you can use DNS over HTTPS. And in these use cases, you will likely also use an MDM solution or an admin portal, where you will, manage and push the configuration to all of your devices. For example, if you have 150 devices, you don't want to go to every single one of the devices and, configure DNS over HTTPS, but you will use some kind of MDM solution that will help you, enforce this, or configure this for every single device and push the configuration to all the devices, at once. The advantage here is that with this agentless deployment, it's location independent. It doesn't matter where the users are located, as long as you configure DNS over HTTPS on their machines or devices, it's going to work no matter where they are. The disadvantage here is, as with the previous DNS location agentless deployment, is that you don't have user context, right? Now, of course, this kind of deployment is not only limited to Chromebooks and tablets and iPads. You can configure this on Linux and Windows machines as well. And I'll also show you in the demo how to do that. So yeah, it's not only limited to Chromebooks and tablets and iPads. Now, now that we've covered both the agentless and the agent-based deployment options, on the right-hand side, you can see what the DNS web filtering configuration page looks like. And there are three different types of scopes or different policy scopes. The first one is access PoPs. This scope is used for agent-based deployments, and it allows you to configure user and group-based policies. The second scope is DNS locations. So this is where you define policies for agentless deployments, so including both the standard DNS locations and DNS over HTTPS. And the third scope is the global all sources scope. And the policies that you configure here are enforced for everyone, regardless of whether the users are using agents or not. Now, when it comes to actions, and the action being here that you can allow or block something, certain URL categories or certain type of traffic, the traffic from access PoPs appears in the web logs because these are agent-based, so you actually have user context here. And the traffic that you from the DNS locations, so both, again, standard DNS locations and DNS or HTTPS, they appear in the DNS logs, and you don't have user context here, right? And then all sources, yeah, this will depend. If you're using agent, it will be in the web logs. If you're not using agent, it will be in the DNS logs. Okay, so we've heard a lot about the DNS access plan now. So which challenges does DNS access plan actually address? It prevents shadow AI, and this is a piece that we're still heavily working on. They'll probably be available in April. It fills your web security filter gaps and regulatory compliance. It protects you, from malware, phishing, and web threats on all of your devices, roaming and mobile devices and office devices. And, complexity and cost. It's very simple and it doesn't cost much. Yeah. So with agent-based and agentless deployments, we have only base level DNS security, right? But we have a lot of customers or many customers that have a higher security demand. For example, they want to have TLS inspection and advanced threat protection and AI content inspection and all the other next generation firewall capabilities. So they may have small branches without hardware, and this is where our internet access plan comes into play. Now, with internet access, what we're doing basically is we are using the agent, the same agent that we're using for DNS security. And what we're doing is we're backhauling all the traffic to our platform or our PoP, where we can then inspect the traffic with TLS inspection and advanced threat protection and antivirus and stuff like that. Now we will have some automatic exclusions for the backhauling. For example, banking information or M365 traffic or streaming media. These will all be excluded from the backhauling. And then also the customers can also add their own exceptions for the traffic that they want to exclude from backhauling, right? And we now also have AI content-based inspection for social media. And that's what we are going to talk about next. So I have mentioned it now quite a few times, this AI-based content inspection functionality. So what does it do? It is a context-aware content inspection. So it basically monitors social media posts of your employees, and then it can report when it recognizes undesired content. And you may ask what's considered an undesired content, and that's what you define with when configuring classifiers. So we have different classifiers. Some of them are, for example, promoting acts of violence or reputational damage, inappropriate language, harassment and bullying, and many more. So you kind of define what's considered undesired content. And it's available for selected social media applications, for example, like X or Facebook, LinkedIn. And, as I just mentioned, this is context-based content inspection, right? And the context really matters in this case. So instead of simply looking at keywords or predefined categories, like we have it with static web filter policies that I just showed. AI understands the context, and it understands how and in what context something is being said, and can then report accordingly if something like that happens. So again, which challenges do we address with the Internet Access Plan? Inconsistent web security for remote and hybrid users. Like I just showed you, you can have this both for your remote and for your office users, for your hybrid users. This doesn't really matter. We cover everything. Lack of visibility into encrypted web traffic. So, for example, we're doing that with TLS inspection, and you can also see that in the logs. Inability to stop advanced and zero-day web threats, and it's easy. It's not a complex solution, and that's slow to deploy, and like many other web security platforms. And we'll also see that in the demo later. And now we can actually come to our private access plan. How does it work? Well, this access plan is pretty much ZTNA use case, right? Or zero trust network access. Now, on the left side, you can see kind of the key factors that are taken into account when deciding whether a user should be allowed access to a specific resource or application. And these factors include user's identity, role-based access control, device posture, and the device itself. So they all help establish both who the user is and the overall security posture of their device. They answer some fundamental questions like, who is the user? Which group does the user belong to? How secure is the device that the user is using? For example, is antivirus enabled? Is the operating system up to date? Is disk encryption turned on or not? And all of these signals are evaluated together to determine, whether the user and their device can be trusted enough to access, a given application or resource. Now, at the center, we have the decision engine. So what it does is it continuously evaluates all the information that it collects from the left-hand side. It processes it in real time and then decides based on configured ZTNA policies and based on the information that it gathered from the left side, whether the access is to be allowed or not. On the right-hand side, you can see the resources or applications that the user may want to access. Now, these can be custom web applications or network-based applications that you, for example, host locally on premises or in your own data center, or also SaaS applications and services, right? Now, for applications that you're hosting yourself in your data center or wherever, you need to install a small piece of software called SecureEdge Connector. And this small piece of software, what it does is it connects your machine or the server where you're hosting your resources and applications, right? It connects it to the SecureEdge environment and kind of makes the resources that you're hosting on this machine available, right, in the SecureEdge environment, and then you can create your policies and stuff like that. Now, this architecture as a whole kind of ensures that only authorized users that are using compliant and trusted devices are granted access to the requested resources or applications. So again, which problems are we solving with private access plan? We prevent the breach impact that you would have with over permissive VPN access. For example, with VPN, you have implicit access. This means that if a breach were to happen, the attacker can actually move through the network laterally, right? And this is what we are preventing with CTNA. It makes secure remote access easy to configure and manage. So you can probably configure everything as ZTNA policy in like less than 10 minutes. You can easily manage the risk that's introduced by contractors and BYOD and third-party users, because you can have separate ZTNA policies for them. You can enroll them with different device profiles and stuff like that, different security measures overall. And you also get full visibility into your ZTNA traffic. So you can see who tried to access which application and when, at what time, and whether that was the access was granted or not. And then finally, we have our premium access plan, which is, like I said, the most powerful plan that we have. Why would you go with premium access? Well, it combines all of the previously mentioned plans into one single plan, and it provides you with the whole functionality set of SecureEdge. So everything that we just talked about. You get your DNS security with basic web filtering from the DNS access plan. You get your firewall as a service with all the next generation firewall capabilities. This is the internet access plan, and you can cover your ZTNA use cases for secure access to the apps that you host yourself, and also for the SaaS apps. All right, enough with the theory. We're now going to take a look at a DNS access demo that I've prepared. First, I'll walk you through the use case, and then I'll show you how this use case is configured in SecureEdge. So let's assume that we have a mid-sized company with approximately 150 users, and this company may have several different departments, including finance and marketing. Now, we're going to use DNS over HTTPS for the general web hygiene policy that is going to be configured for all users in the company. And we're going to block certain URL categories like adult material, violence and weapons, social media, commerce and shopping, and stuff like that. However, marketing and finance require a more granular access. For example, marketing needs access to social media in their daily work, right? And we want to be able to allow them to access social media. Finance needs to access to some financial stuff, like some financial apps or that they need for in their daily work, right? And in this case, for marketing and finance, we're going to use agents, SecureEdge Access agents, for employees in these two departments, in order to be able to create like group-based policies that will allow them to access the websites that they need. All right. So we're now here in SecureEdge Manager, which is our cloud-based management portal. And this is pretty much where all of the configuration takes place and management, right? And to save time in this instance, I've pre-configured the environment. I've pre-configured all the policies, and but we will go through each configuration step, and I'll explain why it has been configured in that way. Now, all right, now the first thing that we want to do is we want to create this global web hygiene policy that kind of pertains to all users using DNS over HTTPS. And if we're going to use DNS over HTTPS, we first need to create a DNS over HTTPS location. And for that, we will navigate to infrastructure and then DNS locations. Now, in here, you can see that I have multiple DNS locations. Don't get confused here. So both DNS, the standard DNS locations where you have an edge device and you have your public IPs, and DNS over HTTPS, they're both configured here in the same place. And the one that we are interested in is this one here, DNS over HTTPS. So let's take a quick look at what we need, what parameters we need to provide when creating this DNS or HTTPS location. So first of all, we need a name for this location. Description is optional, but it makes sense to have it. And for DNS or HTTPS, the description will be, what are you trying to achieve with this DNS or HTTPS location, right? And we want a global HQ security web hygiene, right? Agentless. Then you need to select the region. We are here with East US, and the type. Now, under type, you have DNS over HTTPS. That's exactly what we want. And then you have static and dynamic. And this is for these standard DNS locations where you have, like I said, the edge service, and then you have your public IPs. And then these public IPs can either be static or dynamic. So this is what you would configure here, right? And then you will just enter your IPs, and that would be it. Now, when you create this DNS or HTTP location, you can then see here in the DNS proxy column, you get your DNS server, and you also get your DNS over HTTPS template. And you need both of these, and I'll show you in a second when we configure this on the machine, on the device. We're going to copy this from the SecureEdge manager and configure it on the device. Now, we now actually have everything that we need. We have this DNS over HTTPS location, right? So we can actually take a look at the policy. What would that policy look like for the global web hygiene policy? Now here you can see exactly what I showed you previously. These 3 different policy scopes: access PoPs for agent and for agent-based or user and group-based policies. You can see the DNS location policy scope here. This is for both DNS locations and DNS over HTTPS locations, and all sources, right? Now, the important thing here is the default action. Basically, we can choose between allow, block, and alert. If we go with allow here, we're basically blacklisting. That means that we're allowing all traffic by default, and then we're creating explicit policies that will block certain types of traffic or certain URL categories, right? If we go with block, it's the other way around, right? We're whitelisting. So basically, that means that we are blocking all the traffic by default, and then we're creating explicit policies for the traffic that we want to allow. So allowing the traffic, we're going to go with blacklisting here. And now the global web hygiene policy that we're interested in is right here. So if we take a closer look at it, the scope will be DNS location. And once you configure the policy, you can no longer change the scope. You need to provide a name. I went with HQ web hygiene. Optionally, a description. I think the name pretty clearly suggests what we're trying to achieve here with this policy. The action can be set to block or allow. And then in the source criteria section, if I click here, you'll see that location for the type, there's only location is the possible option here in this scope, in the DNS location scope. Now, we also have here this toggle for all locations. If we enable it, this will pertain to all locations that we have configured previously. But we want the specific, so we'll disable this. And the specific DNS over HTTP location that we've just looked at previously is the HQ, right? So we will select HQ here. In the destination criteria, we'll select URL categories because we want to block certain URL categories. You can also select custom categories here or domains. Custom categories, you can build your own custom categories. You can use the predefined categories and then mix and match, add domains, remove, right? And then you can also select custom categories here. You can also include domains. But like I said, we're going to go with URL categories here. So some of the categories that we want to block are, for example, like I said, adult material, adult recreation, entertainment, illegal or improper security, social media, and also violence and weapons. And now this is basically everything that we need to do. This policy is good to go, right? And now I have a virtual machine here that's running in Azure. And the first thing that we're going to look at, or that I'm going to show you, is how to configure DNS over HTTPS. Now, there's two approaches when it comes to configuring DNS over HTTPS. One is at the operating system level, and I'll show you that one, but you can also configure this on the browser level, right? And most of the time, if you're using Chromebooks and iPads and tablets, you're going to configure this on the browser level. But how do you configure it on an operating system level? You just go here, right click, and then go into network and internet settings. And then based on which type of connection you have here, you'll go to that connection. For me, it's Ethernet. And you're going to scroll down to DNS server assignment here. You're going to click on edit, and you have to select manual here, right? And then you have to enable IPv4. So basically, this is exactly the DNS server that we have here. See? And also this template, we can also copy the template here. And that's basically all we need to do. We just hit save, and that's all we need to do, right? Now let's see if what we configured actually works. So we said we are blocking social media. So if we go to Instagram.com, we should get a block page, right? What else? We also have, for example, guns blocked. For example, if you go to block.com or guns.com, we'll also get the block page. And what else did we block? We blocked also, for example, shopping and commerce. So if we go to Amazon.com, that should also be blocked. So we see it works, right? And you've seen how easy and fast it is to configure this. Now, before we switch to group-based policies for marketing and finance, we need to somehow add our users, because we're going to use SecureEdge Access Agent, and we're going to download and install it on the devices. So before we do that, we need to add our users somehow. And for that, we will go back to the SecureEdge Manager, and we'll go to Access. And we'll go to Identity and then Settings. And as you can see here, we can configure our identity providers here and also our user directories. I configured Entra ID for both, as identity provider and for user directories. But if I click here on Add Identity Provider, you can see that we offer many options, right? Microsoft Entra ID, OpenID, Okta, SAML 2.0, and the same goes for user directories here, right? Also Okta, LDAP, SEIM, Entra ID, Google Workspace. Now, once we've done this, we can actually see the groups and users which have been kind of added to the environment, and we can exactly see here this marketing group and the finance group. Now, I've added only one member in each of the groups just for demonstrational purposes, but this will be the interesting one because we will use this user to kind of demo the group-based policies, right? Now, we also need to somehow, we've added our users, right, to the environment, but we also need to enroll them somehow. And for this, we will move to infrastructure and then, not access and then enrollment. And here you can see pretty much the list of all the users that have been enrolled in this environment, right? And here you can also see the type of licenses that are using. For example, these 4 are using premium. This one is using DNS, right? And Now, there are multiple different ways of enrolling users with the SecureEdge Access agent. You can do it group-based, you can do it token-based, you can do it on for a single user. One is, for example, to send this managed link per email to your user. And this is what this basically looks like. So first, they need to download the agent and install the agent, and then they can simply click here on enroll, and then just in a few quick steps, they'll be enrolled and ready to go. Yeah. So I have now another machine here, also running in Azure, and I have installed SecureEdge agent here. And as you can see here, I've enrolled this user that's part of the marketing group, right? This is this one here. And if we now actually go to the web browser and try, so we said we wanted to allow social media, for example, for the marketing group, right? So if we go to facebook.com, we can see that we can access this without any problems. We also wanted to allow, for example, shopping, right? So if you go to amazon.com, that will also be possible, but we also said that we want to keep some of the URL categories blocked, right? For example, guns.com should still be blocked. And now I remembered, I forgot to show you what the policy actually looks like for this user-based or group-based policy. So let's go back to, we see that it works, right? Now let's take a look at the policy really quickly here. I'm looking at the time. I have to be mindful of that. So the policies are the security, web filter, and then policies. And now this policy that's interesting to us for marketing is under access PoPs, because now we're using group-based policies, right? Again, this is the policy that we're interested in. We have scope. The scope will be access PoPs because this is a group-based policy. For the name, I went with marketing, business enablement access, and we want to exactly allow socials and commerce for marketing and shopping as well. The action will be block. It might sound counterintuitive here, but you'll see what I mean. This is the option to silently block the rule. We don't want that. And then in the source criteria section, if I click here, you can see that the only option here is user or group, right? Again, we have this all users toggle here. So if we enable it, it will pertain to all the users. It will be configured for all the users. And we want but we want specific user group, and that's marketing, right? So that's why we selected marketing here in the groups. And the destination criteria will again be URL category. And now we said, for example, we still want to block some of the URL categories that we blocked previously with the DNS global web hygiene policy, right? So we still want to block adult material, adult recreation, violence and weapons. But for example, in this case, I deselected social media because we want to allow marketing access to social media. And for example, also commerce and shopping. And that's why, if we go back one more time, that's why you can actually, access the social media without a problem. And you can also access, like I said, Amazon.com, if this works today. And for example, guns.com will be blocked, will still be blocked, right? And I have no idea why this is loading now. Yeah, now it comes. So you're able to access both Amazon.com and Facebook.com. And now, looking at the time here, I'm not going to go through the policy for the finance group. I would actually like to quickly go back to the slides. So what can you do next, right? You can review the available resources. You can contact your channel business manager, solution architect for a demo, and you can assess your customer base for upselling opportunities. Remember, DNS access, the most basic DNS access plan, is a perfect way to set your foot in the door with Secure Edge. And then you can build up from there.